Hello everyone, Assalamualaikum warahmatullahi wabarakatuh and good day to every one of you. Welcome to my video. So this is actually a lecture video for subject Electrical Circuits 1 code BEV 10303. Okay, so in this video we are going to continue on our discussion for chapter 2, Basic Law of Electric Circuits. Okay, so basically what are the contents that we are going to cover in this video? We will see in details what is the difference between series resistor circuit and the parallel resistor circuit, as well as the concept of voltage division rule and the current division rule. So now we go to the first topics for today, which is the series resistor circuits and the voltage division. Okay, for the series circuit, so basically this is your example for your series circuit. Okay, so a series circuit is a circuit which provide only one path for the current to flow between the 2 points in the circuit. So you can see here, you only one path for the current. Okay, so the current will flow from this supply from the positive terminal to the negative terminal. So when you have only one path, so meaning that this is the series circuit. Okay, so your series circuit can be drawn in terms of the equivalent circuit like this. Okay, where your RT now is the R equivalent for the R1, R2, R3 and so on. Okay, right. So for the series circuit, it's actually the total resistance is equal to the sum of the resistance of each of the individual resistors. So in this case, your RT, your total resistance is equal to R1 plus R2 plus R3 plus ... until your Rn. Okay. So the current is the same through each of the series components. Okay, because from the previous slide, you know that the series circuit provide only one path of the for the flow of the current. So that's why the currents remain the same through each of the series component. Okay, so your I is equal to voltage over R total, which is R equivalent. Okay, so the voltage drop at each of the elements are different and it depends on the value of the R. So here you have V1 is equal to I multiplied with R1, V2 is equal to I multiplied with R2, V3 is equal to I multiplied with R3 and so on. Okay, so in this case, remember for series circuit, the current is same at each of the series component, but the voltage drop are different. Okay, so this is the two important things that you must remember. Alright. So for voltage drop of each element is given by this formula. Vn is equal to I Rn. Okay. Alright. The power dissipation at each of the element is given by Prn is equal to I multiplied with Vn, because each of the elements will have different voltage drop. So that's why the power dissipation at each of the elements also will be different. Alright. So you can either use P equal to IV or P equal to R or P equal to V squared over R. Okay, so your power dissipation depends on the value of the voltage drop at each of the elements, or it can also depend on the value of the resistance at each of the elements. Alright. So the power supplied by the source is equal to the total power dissipation by each of the elements. Okay, so your P equal to IV, and P, the power supplied by the source, is equal to the total power dissipation by the R1, R2 plus R3 and so on. Alright. Okay. So let's go for the example. Let's say you are given this kind of circuit. Okay. So where you have a supply 20 volt connected in series with 2 ohm and 3 ohms. And then V1 is a voltage drop across 2 ohm. V2 is a voltage rise across 3 ohm. And you have supply 20 volt. Alright. So based on the circuit, you need to determine the equivalent resistance. So what is the R total? And then determine the current flow through each of the element. Okay. And then you need to determine the voltage across each of the elements. So then you need to calculate the power dissipation at each of the elements. And then lastly, you need to calculate the power supply by the source. Alright. And then after that, based on the value that you get, you need to give a relationship between the answer in 3 with the voltage source. So you need to compare your answer, how to relate the voltage drop at each of the elements with the voltage source. Okay, and then finally the last question is give a relationship between the answer in 4 and 5. How to relate the relationship between the power dissipation at each of the element and the power supply by the source. Alright. Okay, for the solution to the question, for this series circuit, because you know that for the series circuit, it only provide you of one flow path of your current. So that's why in this case, we assume I is like this. Okay, so I flow from the positive terminal to the negative terminal. And then for the R total is equal to R1 plus R2. So in this case, 2 plus 3 is equal to 5 ohm. And then the I now is equal to V supply over the R total. So V supply is 20 over 5 is equal to 4 ampere. And then you need to calculate the voltage across each of the elements. So in this case, V, according to the Ohm's law, V is equal to IR. So in this case, V1 is equal to I multiplied with 2 ohm. So 4 multiplied with 2 is 8 volt. For V2, okay, for V2, because of the current flow from the negative to the positive terminal, so that's why in this case, you need to use formula V is equal to negative IR. So in this case, negative 4 multiplied with 3 ohm. So the answer is negative 12 volt. Okay, so now what is the relationship between the voltage across each of the elements with the voltage source? So we know that the sum of the voltage drop is equal to sum of the voltage rise. So in this case, voltage drop is equal to 8 volt. And the sum of the voltage rise is equal to 20 minus 12, so equal to 8 volt as well. Alright. Next, we need to calculate the power dissipated by each of the resistor. So in this case, you can either use formula P equal to IV or P equal to I squared R or P equal to V squared over R. Okay. So in this case, I'm going to use this formula. P equal to IV. So P1 is equal to I multiplied by V1. So from here, from the previous slide, you know I is equal to 4 ampere and V1 is equal to 8 volt. So that you have P1 is equal to 4 multiplied with 8. So you get 32 watt. Okay. So for P2, by using the passive sign convention, you know that when your current flow from positive to negative side, so you are using this formula. But when your current flow from the negative side to the positive side, so you need to use P equal to negative IV, right? So in this case, negative I is 4 multiplied with V2. V2 is negative 12, so you get 48 watt. So finally, your P total, meaning that the total of the power that dissipated by all the passive element is equal to P1 plus P2. So in this case, 32 plus 48 is equal to 80 watt, alright? And then, how much is the power supplied by the source? So, same thing, your current now is a flow from the negative side to the positive side. So, that's why you are using P equal to negative IV. So, in this case, power supply by the source is equal to I multiply your V is 20. So, negative 4 multiplied with 20. So, equal to negative 80 watt. Okay. So, the relationship between the power supply by the source and the total power dissipated by each of the elements is given by the total power dissipated by load is equal to the total power supply by the source. So in this case, here you have 80 and here you have 80 as well. Alright. So now we are going to see the concept of voltage divider rules. Okay, so again, this is your series circuit and then this is your equivalent circuit for your series circuit. Okay, so for your series circuit, you are given V supply and then connected in series with R1, R2, R3 and so on until your Rn. Okay, so based on your KVL, you know that KVL saying that the total of the voltage drop is equal to the total of voltage rise. So in this case, your voltage drop is equal to V supply is equal to V1 plus V2 plus V3 dot 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 until your Vn. Okay, and then after that you can apply your Ohm's law to each of the elements. So you know that according to the Ohm's law, V1 is equal to IR1, V2, IR2, V3 is equal to IR3 and Vn is equal to IRn. Okay, so that's why you can substitute this formula. And then after that, because I is remain the same for each of the elements, so that's why you can factorize the I to the outside. So V is equal to I factorize R1 plus R2, R3 and Rn. And then finally you can rearrange this equation so that you can get I is equal to V over R1 plus R2 plus R3 and plus Rn. Okay. Finally here R1 plus R2 plus R3 plus dot 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 Rn is equal to your RT. So R equivalent. So finally, I is equal to V over RT. Okay, so here you can consider it as your equation number 1. Okay, so next, this is from the Ohm's law. Okay, I had recalled it just now. So V1 is equal to IR1, V2 IR2, V3 IR3, Vn IRn. And then this one we consider as the equation number 2. So you can substitute your equation 1. So this is your equation 1, I equal to V over RT, into your equation 2 here. So you can get your V1 now is equal to I is V over RT. So V over RT multiplied with your R1. So V2 is V over RT multiplied with R2. So your Vn is equal to V over RT multiplied with your Rn. Okay, because your I is equal to V over RT. Okay. So based on here, you can see that you can rearrange it so that you can have Vn is equal to Rn over RT multiplied with your V. Finally, we can formulate the voltage divider as Vn is equal to Rn over RT multiplied with your V, where your Vn is a voltage to calculate, okay, and then your Rn is the respective resistance, okay. Okay, so for the example, you need to calculate, based on the following circuit, you need to calculate V by using the voltage divider rules. Okay, so from the circuit, you see, V is actually a voltage drop across this point to this point. So meaning that the V is equal to voltage drop across 60 ohm plus 20 ohm. Okay, so by using the voltage divider rule, Vn is equal to Rn over Rt multiplied with V. So Vn is actually the voltage to calculate, and then the Rn is the respective resistance. So in this case, your Rn is 60 plus 20, right? So because your V is from this point to this point, so Rn is the 60 plus 20, okay? So that's why you have 60 plus 20 over your R total is equal to 60 plus 20 plus 40. This is the R total. So here you have 80 over 120 multiply with 120 volt because your supply is 120 volt. Okay, so finally the answer is equal to 80 volt. Alright, so that's all for now. Thank you for your time and thank you for watching my video. I'll see you in my next video. Okay, bye.